So, if I tell you about the old video games, chances are that Pong will pop into your head pretty quickly. Those were the good old times, where just a couple of rectangles were enough, and we didn't need all those amazing graphics, and complex mechanics, and long narratives. Of course, this was also a time where you didn't actually program stuff on a computer, but rather welded your game directly as a hardware electronic circuit, which kinda explains why Pong was way simpler than our modern games. But since then, the tech has evolved, and we've now got incredible tools that... You know what? Let's cut this short. Wanna learn how to make Pong in Godot? Cause that's actually not that hard, and it can teach you a lot about this game engine. Oh, and by the way, stick until the end for a little surprise. Now, just before we dive in, also a big thanks to my Patreon and YouTube members who make all of this possible, and in particular to Mark and Kaicho, my newest Patreon line members. If you want to get regular extra assets and demos, plus support my work, be sure to have a look over there and consider joining us. Okay, now to begin with, as a quick reminder, every Godot scene is made of a hierarchy of nodes, or in other words, a tree of little elements that can each be of one of the many built-in types and therefore have a bunch of more or less specific methods and properties. So for example, you can use meshes, cameras, lights, rigid bodies, colliders, skeletons, and many more ready-made node types to create your scenes. And then of course you can slap some GDScript or C# logic on them to further customize their behavior and actually make your game-specific features. And also as a quick note, this engine sorts the built-in node types in 3 categories. You've got the 2D nodes with a blue icon, the 3D nodes with a red icon, and the UI or control nodes with a green icon. In this tutorial, since we're working on a 2D game, we'll be using the 2D and control categories, meaning that each and every node in our scene will be of type that derive from either the node 2D base type or the control base type. Alright, now with all that in mind, it's time to start working on our Pong scene. The setup for this game is actually pretty simple. If we look at a screenshot, we see that we have one paddle per player on each side of the screen, the ball that moves across the screen, walls at the top and bottom for it to bounce off of, a line in the middle to visually separate each player's side, and finally some score labels at the top of the screen. So for now, let's focus on the environment, meaning the black background, the white line in the middle and the horizontal white walls for a ball to collide with. When you start up a new project, you'll notice that Godot auto-creates an untitled empty scene. So all we have to do is start up our node hierarchy and then save this scene. To do that, we need to add a root node that will determine the type of scene that we're working in. Here we're going to use a control node, which we can do by clicking on the user interface option in the top left panel. You see that this panel now shows us our scene hierarchy that contains a control root node. This control, like any other interface node, can auto-resize dynamically to handle responsive screen layouts, which is really cool and handy. And by default, you see that this root UI node perfectly matches the screen size for our game that is shown in the viewport with this thin blue line. Okay, so we can save this beginning of a scene as something like game.tscn, where tscn is Godot's extension for scene files. And finally, for good measure, let's go to our file browser panel in the bottom left corner, right-click on this new scene file, and make it the main scene. This tells Godot that when we run the project, it should start with this scene first. Alright, now let's take care of the background. To give a uniform black color to our scene, the easiest solution is to create a new node as a child of our root node, this time of type colorRect. As the name implies, this node creates a basic rectangular uniform color visual. And its icon is green, meaning it's also a UI node, it inherits from our base control type, and so it can also adapt to the screen size. Now, when you add it, you'll notice that it actually doesn't match the screen size, it's stuck to the top left corner. But the trick here is to open this little menu at the top of the viewport panel, where you can pick the anchor preset for any control-derived node. Some presets will stick the node to a corner, like here, or a side, or to the center. In our case, however, we should use the full rect preset over here, to force our color rect to stretch to the size of its parent node, because as we saw before, its parent is the root node that itself stretches to the whole screen size. Then to make our color rect black, all we have to do is select it and on the right, in the inspector panel, change the value of its color property. Of course, if you want, you can also double-click on the node's name in the hierarchy to rename it to something clearer like background. And let's also rename our base control as root while we're at it. Okay, so that's nice, but we've just created a background. Now for the line in the middle, we can actually use a very similar technique. Because let's say that we select our background node and we duplicate it. Then we'll reset the color of this new node to white by clicking on this little undo arrow. By the way, that's a neat feature of the Godot editor that allows you to quickly revert any property on any node to its default value. And so now if we change the anchor mode of this duplicate to be centered horizontally and stretch vertically, we should get a vertical line in the middle of the screen, right? Well, it seems like our rectangle has actually disappeared. That's because our centered horizontal anchor also shrinks the node horizontally. To make it visible, we need to force its minimum width, which we can do by changing the X component of the node's custom minimum size. So at this point, this vertical line will always be at least 2 pixels wide, and it will stretch vertically to match the current screen height. Now, last but not least, we need to work on our walls. This is slightly more tricky, because contrary to the background and the split line, those elements aren't just visuals. They need to be actual physical objects that our paddles and ball can collide with, and this is only possible by defining 2D bodies and colliders. More precisely, we need to structure our wall object as follows. First, we'll create a static body node. This node type exists both in 2D and 3D, but here we'll obviously go for the 2D one. And this static body type is one of Godot's physics body types, and it's pretty self-explanatory. It's the type of node that you want to use whenever you need to make fixed, static objects in your scene, but that collide with other physical objects and block them if need be, like most of the stuff you put in your environment. Then, as explained by this little warning sign on our brand new static body 2D node, we need to give it a child node of type collision shape 2D. This is Godot's way of defining physical elements in a scene, be it 2D or 3D. You have a body parent node, and then inside you have a collision shape node as a child that specifies the physical shape of this body in the scene. Though for now we have another warning, because our collision shape child node doesn't truly have a shape yet. For that, we have to go to its inspector and at the top create a new data resource for its shape property. So that's the next important thing to remember when doing Godot scenes. Scenes contain nodes, and nodes use resources to power most of their behavior. Those resources are used in various places, usually behind the scenes, and they can be defined on the node itself, in which case they're embedded in the scene, or they can be saved as a file in the project, and then shared between nodes, even across scenes. In our case, we'll stick with an embedded resource. We'll create a new rectangle shape 2D resource. Godot shows us this collider as a blue overlay in our viewport, and we can now play around with its properties to change its shape and roughly match the width of our screen. However, if we try to run our game by clicking on this little icon, we don't see any wall at the top. And that's because colliders are just physical objects, they're not visible elements. This blue overlay is just a debug thing in the editor. To actually see our wall, we needed to give it a 2D visual. Now, there are various ways of doing this, like loading up an image as a sprite 2D, an animation sequence with an animated sprite 2D, or even a puppet-like 2D rig with a skeleton 2D. But here, our walls are simply basic rectangles, so we can create them directly in the engine, on the spot, using a polygon 2D node. When this node is selected, you'll notice that you have those extra commands at the top of the viewport panel to add, move or delete points in this polygon. Or if you prefer, you can edit those points more accurately in the inspector by opening this array of 2D positions assigned to our node's polygon property. Either way, you see that this time we don't have a responsive auto-resizing visual. Sadly, 2D nodes use absolute pixel positions and sizes. so we need to manually set it to the proper width, and if we were to resize our screen, this wouldn't fit anymore. And now that we have one wall, we can duplicate it and drag this other copy to the bottom of the screen to get the other border. Alright, now if we rerun our game, we see that our environment is all set up. Okay, so this is cool, but it's a bit static, and you don't have a lot to do as a player in our current Pong game. So time to add some pedals and link them to our player inputs. Here our goal is to have 2 pedals and have 2 inputs move the left pedal up or down, and 2 other inputs move the right pedal up and down. Of course, this is a pretty crude local co-op couch game system, but it will be enough for this tutorial. In Godot, whenever you want to have a physical object that can collide with other stuff, like the walls or the ball in our case, but also be moved manually, meaning that you code its behavior via a script, you'll usually want to go with a character body node. Again, it exists both in a 2D and a 3D version, so here we'll go with the 2D one. Let's add it to our scene, and we can start by changing its motion mode to floating in the inspector. Because here we're not making a side-scroller game with gravity, but more of a top-view setup with no gravity. Of course, once again, Godot warns us that this body requires a physical shape, so we need to create a collision shape 2D node inside it, and then give this child node a shape resource. Again, we can use a rectangle, but to be sure this collider fits the visual of our paddle, let's start by creating a polygon 2D in our sub-hierarchy and drawing our rectangle. Feel free to adjust the dimensions of the paddles to your liking to make the ball easier or harder to catch. Then we can make our collider the same size as our polygon. You may want to put it lower in the hierarchy so that it's shown in front and you're sure it has the right size. And so to sum up, this paddle will show as a basic white 2D rectangle on screen when we're in-game, but it will also be a physical object that can collide with the other ones and be moved by code. And speaking of code, the next step is to write up some logic to make it actually move when we press some keys on our keyboard. First, to create and directly attach a new script on this node, we can select it in the hierarchy and use this button at the top. This shows us a pop-up where we can select what language we want to use, optionally a list of templates, if there are some for this type of node, to autofill our script with ready-made logic, and finally, here we can set the path and the name of our script file in the Godot project. For example, here I'm calling it paddle.gd and I'm saving it at the root of our project. Also, note that here I'll select the GD script language, but I'll actually show you how to write it in both GD and C# in just a second, and we'll stick with an empty template to really work from scratch and understand what's happening. If we open this new script in our IDE, or alternatively in Godot's built-in code editor, but I find it a bit lacking in terms of tooling, especially for C# code, we see that for now, the script is pretty empty. Although Godot did make sure that we inherit from the character body 2D class, since this was the type of the node that we had selected when we created it. So the first thing we need to do is define which inputs control this paddle, depending on whether it's the left or the right one. For that, we can define a new variable in our script of type int and use Godot's variable export system. In GDScript it's the @export symbol, and in C# it's the export attribute. This way, when we save our script, go back to the editor and select our character body node that has our script attached, you see that this variable now appears in the inspector, and so we can edit it easily and set a different value for every node that has an instance of our script. If you're working in C#, meaning that you have a C# version of the Godot editor and you've written your script in C#, don't forget to manually recompile the project with this button in the top right corner to have the exported variable appear in the inspector. And if you don't have this button, be sure that your C# solution was properly created by going to the Project Tools menu. Then, to know if there currently is an interesting input, meaning one of the two that corresponds to our current player ID, a nice solution is to use Godot's built-in input hook. This function is called whenever there is an input. It can be a key press, or a mouse click, or a mouse movement, or a gamepad interaction, or even better, we can check for an input action. If you're not too familiar with the concept, input actions are a way to abstract inputs to make them more flexible and more cross-platform. Basically, instead of writing code with exact device-dependent checks, you instead use an intermediary layer of abstraction, with actions that each have a unique name. And so you use those names in your script, and then you link the real device inputs to these actions. This way you can super easily modify the device inputs that trigger an action, or add multiple ones, and even connect different types of devices to the same action without having to change anything in your code. To do this in Godot, it's pretty easy. All we have to do is open up our project settings panel, then go to the input map, and use this input field to type in the name of a new input action. Here I'm going to define an up and a down action for each player, so I'll add a suffix with the ID of the player that I want to be controlled by these inputs. Then, to actually define the device inputs that trigger an action, we'll use the plus icon on the right and either browse the list of possible device inputs or just press the key on our keyboard to have the engine auto-select it for us if it's a key press. So here's what these input actions could look like for our Pong game when we're done assigning our inputs for all 4. And so now that we have those input actions, we can come back to our paddle script, and in the input function, we can check if the event that triggered this hook is either the up or down action matching our player ID. Now, to move our paddle, because it's a physical object, the best and less error-prone method is to update our object's velocity. This is an inherited property that comes from our character body 2D parent class, and also here you notice 2 important things about moving stuff in 2D in Godot. 1, the dimensions and distances are all in pixels, so you'll usually use pretty big values, and 2, the y-axis points down, so going in the up direction means having a negative velocity. Also, we needed to ensure that when we release an input key, the paddle actually stops, so we need to reset its velocity. Otherwise, it will just keep moving in the direction that we gave it forever, even after we released the input. The last thing we have to do to truly make our paddle move is apply this velocity. To tell the engine to use the current velocity of the object and recompute its position based on it, we've got to implement another built-in hook, the physics process function, and call the move and slide inherited method inside it. This method is an update hook that is called at a fixed frame rate and is therefore great for physics computations or updates. The move and slide method uses the velocity property of a character body to the derived node and applies it to update the node's position. If we retry our game now, you see that if I press the up and down inputs associated with the player 0, my paddle indeed moves up and down, and it even collides with the walls. The final step is to create our second paddle, but before that, it would be nice to make this paddle a prefab. This way, if we decided to change anything, the changes will be reflected on every instances instantly. To do that, we can right-click on our character body node in the hierarchy and save it as a new scene. Because, yeah, in Godot, prefabs are just scenes like any other. After all, they're just a smaller subtree of nodes. Now we see that our paddle object has a little icon in the hierarchy to indicate it's an instance of another scene, and if we click on it, Godot opens this prefab scene, and we can edit it just like our main scene. For example, we can reset the position of the paddle to 0. If we save the prefab scene, and then come back to our main game scene, you see that our paddle instance indeed got teleported back to the origin. So now let's copy it to get our second instance, and both paddles are linked to this reference prefab. To place each paddle in the right position, we can edit its position property in the transform subsection, and the really nice thing is that we can even compute stuff directly inside our input, and Godot will auto give us the result. So if we open up our project settings panel and take a look at the window options to know what the default screen size of our game is in pixels, we can then use these values to place our paddles in the middle vertically, and, for example, 64 pixels from the border on each side. Also, on the right paddle, don't forget to update the player ID to 1 so that it uses different inputs. And there we go. We've now got 2 paddles that each react to a different set of inputs, and that collide with our scene environment. Alright, so now that we have our paddles, we need to actually have something to hit and play with. Our ball. And this element will be pretty similar to our paddles actually. We'll make another character body 2D node with a polygon 2D for the visual and a collision shape 2D node that uses a rectangular collider. Then we'll give it a new script called ball, and inside we'll define our physics process hook, where we'll call the move and slide function. Then to give this ball an initial velocity, we'll make another method called initialize, where we get a random angle and use some cosinus and sinus to transform it into the corresponding 2D vector. We'll also make sure that we reset the position of our object to be in the middle of the screen, which we can do like this. First we get our render viewport rect, and then we get the size of this rect, which is therefore the size of the screen, and divide it by 2. Finally, we'll use the ready built-in hook, which is called when a node with this script is instantiated in the scene, to call this initialize method and truly run our logic. And if we try this out, well, we see that our ball indeed gets a random velocity and then simply travels in that direction. And if you restart the game, you'll get a different direction every time. But obviously, there are a couple of issues here. One, if the initial velocity is too vertical, the ball gets a bit stuck, and this doesn't look great. So we should refine our angle computation, like this for example, to instead have it always go somewhat horizontally. Here we first get a random float between 0 and 1, and then we use that to have a 50-50% chance of going left or right, but with a smaller possible angle amount. 2. When the ball gets out of the screen, nothing special happens, and so we're kinda just left with nothing more to do. Yeah, so we kinda need to respawn the ball at one point. And 3. If the ball hits a paddle or a wall, it simply glides along it, instead of bouncing off it. So we need to fix this, and have the ball go in a mirror direction if it hits a paddle or wall. So to detect if our ball is off-screen, we can use a cool Godot node called the visible on-screen notifier 2D, and add it inside the sub-hierarchy of our ball. In a nutshell, this node tracks the position of a given 2D region, and if it enters or exits the screen, it emits a signal, an event, that we can react to in our code to run some callback logic. So let's go to this notifiers inspector and update the region so that it matches the size of our object. And then we'll go to the top of this inspector and switch over to the Node tab. This new panel shows us the list of signals available on this type of node. Godot's signals are basically events. They're emitted at specific moments, and you can link one or more callback functions to them. Typically, here we want to react to the screen exited signal. So let's double-click on it. This opens up the signal binding pop-up, where we can pick or create a new callback function for this signal in the script of one of the nodes in our scene. In our case, we want to define our callback in the script on the ball character body node. So we'll select it, we'll simplify the name of the callback function a bit, and finally we'll click the connect button at the bottom. This auto-creates a function in our script that will trigger when this signal is emitted, meaning in our case, when the ball leaves the screen. So when the ball gets out of the screen, we needed to do two things. One, the player on the other side needs to score a point, and 2, after a little delay, the ball needs to reset in the middle so that the game can continue. Now, we'll talk about scoring in just a minute, but for now, let's make sure that we can resume the game. First, we'll use this line to tell Godot to wait for 1 second. This looks a bit complicated, I know, but in short, we're simply creating an on-the-fly timer with a countdown of 1 second, and then we're waiting for its timeout signal to emit, or in other words, for this temporary timer to end. Then, when this second has passed, we'll call our initialize function again. And that's it. Now you see that as soon as the ball exits the screen, it waits for 1 second, and then it respawns in the middle. The other issue we have to fix is that the ball is not bouncing off colliders. For that, there's in fact a pretty cool trick. Rather than using move and slide in the script's physics process, we can use another variant that is called move and collide. Why? Because this variant returns an object with some info on the collision that just happened. And so if there was a collision, we can get the normal direction of this collision and bounce or velocity relative to it using this pretty cool built-in function. Though be careful, cause contrary to move and slide, move and collide doesn't auto-apply the time delta, so we have to multiply our speed by the delta parameter that Godot passes to the physics process hook automatically to keep the right ball velocity. Okay, our ball now properly bounces off the walls and the paddles, and this is starting to look a lot like a real Pong game. The last thing we need to implement is some score system, so that we can tell who's currently winning. Okay, so for the score mechanic, the first thing is that we should create 2 new UI nodes in our scene, 1 label per player, to show the score of each one. For that, we can use Godot's label node type, and then, to display those nodes on each side of the field, aligned horizontally, we can wrap them inside an HBox container. This HBox container node is, as the name hints at, a UI container node. There are a bunch of them in the Godot game engine, and in short, they are like clever UI elements that auto-place all their child elements in some specific way. The HBox container puts them in a row, the VBox container puts them in a column, the center container forces them to the center of its own area, and so on. If you're curious about that, I actually made an entire video on why Godot's UI containers are great and how to use the most common ones. But anyway, here, by putting our label nodes inside this HBox container, we've stacked them horizontally. So now, by forcing this HBox to expand horizontally to the full screen width, and also force the child label nodes inside to stretch and expand, then you see that both our labels occupy half the width of the screen. And again, this is completely responsive, so if we were to shrink or stretch our screen size, everything in our UI would follow properly. Finally, we can change the horizontal alignment property of both our labels and center the text, and we can also go to the Theme Overrides section that contains a bunch of styling options to change the font size and make our labels a bit bigger. Okay, so this looks nice, it's time to use those labels to display some real scores. Now, in a more complex game, you would probably have a game manager to take care of global states and things such as score. But in our case, since the score is tied to the player, and we've already got a script on both paddle that basically represents the players, we'll simply add the score logic to this script. So first, at the top of the paddle script, we'll define a new variable of type int to hold the current score. It's initialized to 0. Then we'll create a new method called incrementScore. This method needs to do 2 things. First, it will add 1 to this integer to actually increment the score of the player, and then it will update the matching score label. To reference the score label node, we can use another export variable, this time of type label, and then in the inspector of each paddle object, we'll assign the matching score label node. This way, in our script, we can modify the text of our label to be our new updated score stringified. For a fancier look, we can even use string formatting utilities and ensure that our score is always displayed with 2 digits, optionally using a 0 prefix, like in the real Pong game. The last point, of course, is to call this method somewhere, and more precisely, when the ball exits on the opposite side. Because remember that when the ball exits the screen on the left, it means the player on the right just scored, and vice versa. To do this, we're going to add a few things to our ball script. First, we'll export 2 new variables, 1 per player paddle. And then, in our screen exited signal callback, before we respawn the ball, we'll check which side the ball is by simply looking at its x horizontal position and call the increment score function of the player on the other side. And well, that's about it. If we replay our game now, you see that the ball properly spawns with a random angle, and then it travels along this given direction. We can use our inputs to move either the left or the right paddle, and if the ball hits a paddle or wall, it bounces back by updating its velocity. Finally, if the ball exits the screen, the player on the other side gets 1 point, as is shown by the matching score label, and the ball respawns after 1 second. Now, this tutorial has already been packed with a lot of info, but of course there's also a lot of things that we could add to improve the game feel, like VFX, screen shakes, and sounds. So if you want to learn more about that, tell me in the comments down below, and I might do a follow-up episode. Thanks a lot for watching, and as promised, here's a little surprise. I'm actually working on a new game. It's an idle game about stars, and I'll talk about it more in an upcoming video. But if you're curious about the project, and you want to help me make this game, check it out on Steam, add it to your wishlist, and perhaps even check out the demo that is now available. Also, if you want to start making your own games in Godot, you might want to have a look at this video where I explain the 60 most important Godot node types in 6 minutes. And of course, don't hesitate to subscribe to the channel to learn even more game creation tricks. As always, thanks a lot for watching, and take care.